Imagine a world where computers are millions of times faster than what we have today. A world where solving complex problems that once took centuries could happen in seconds. Every year, technology gets a little bit closer to that reality. Our smartphones, tablets, and laptops are evolving, becoming more powerful and faster than ever. But how did we get here? From the bulky computers of the past that filled entire rooms, we've shrunk down to pocket-sized devices that can access almost all of human knowledge in seconds. At the heart of all this progress is one crucial component: the processor. But as we push the limits of these traditional computers, we're running into physical boundaries that can't be crossed. So, what's next? What will power the future? Quantum computers, machines that promise to change everything we know about computing. In this video, we'll dive into the world of quantum computers and explore how they work. But first, let's understand how our current computers have paved the way for this quantum revolution. As you know, mobile phones, tablets, and laptops are all types of computers. Whether you're texting, browsing the web, or watching a video, your device is processing tons of information using its processor, also called the CPU. The CPU does all the processing with transistors, tiny switches that can either be on or off, just like a light switch. In computer terms, on is represented by the number 1, and off is represented by 0. These ones and zeros form the basis of how all computers process information. This brings us to bits, which stands for binary digits. A bit is the smallest unit of data in a computer and can either be a 0 or a 1. By combining these bits, computers can create letters, numbers, images, and much more. For example, the letter A is just a combination of bits like 0, 1, 0, 0, 0, 0, 0, 1. Next is the byte, which is 8 bits put together. Just imagine. Every piece of data you see on your screen is made up of millions or billions of these bits and bytes. But as technology advanced, humans began to reach the limits of what traditional computers could do. To keep making processors faster, we had to keep adding more transistors, and as a result, shrinking them. Today, they are almost the size of atoms. This leads to a new problem. At this incredibly tiny scale, a strange phenomenon known as quantum tunneling occurs. Electrons can pass through the barriers between transistors, causing errors in processing. So, how do we go beyond these limits? The answer is quantum computers. To understand how quantum computers work, we first need to explore the fascinating concept of superposition. In the world of classical computers, information is processed using bits, but in the quantum world, things get much stranger. Thanks to quantum mechanics, the smallest particles, like electrons or photons, don't just exist in one state, they can exist in multiple states at the same time. This is what we call superposition. Imagine flipping a coin. In the classical world, the coin can either land as heads or tails, but in the quantum world, it's as if the coin is spinning, and it's both heads and tails at the same time until you observe it. Quantum computers use this concept of superposition to process information in a totally new way. Instead of bits, quantum computers use qubits, which can be both 0 and 1 at the same time. This allows them to perform many calculations all at once. For example, a classical computer would check one possible solution at a time, but a quantum computer can check multiple solutions simultaneously, making it incredibly powerful for solving complex problems. Think of it this way: While a regular computer would be like searching for a single key on a keyring, checking one key at a time, a quantum computer can try multiple keys at once, finding the correct one much faster. This ability to process vast amounts of data at the same time gives quantum computers the potential to revolutionize fields like medicine, cryptography, and even artificial intelligence. Now that we know about superposition, let's talk about the core of quantum computers, qubits. While classical computers use bits, units that can only be 0 or 1, quantum computers use qubits, which are much more powerful. But what exactly is a qubit? A qubit is the basic unit of information in a quantum computer. What makes qubits so special is their ability to be in multiple states at the same time, thanks to superposition. While a classical bit is like a light switch, either on or off, a qubit is more like a spinning coin that can represent both heads and tails at once until you look at it. One way qubits are created is by using the spin of electrons. Electrons are tiny particles that can behave like spinning tops. In the quantum world, these electrons can have either an up spin or a down spin. Think of it like a compass needle that can point up or down. But here's the amazing part. In quantum superposition, the electron can have both spins at the same time, up and down. This ability allows qubits to hold more information than classical bits ever could. Because qubits can exist in multiple states at once, quantum computers can process much more data simultaneously. Imagine trying to solve a puzzle. A classical computer has to try each piece one by one, but a quantum computer can test many pieces all at once, making it much faster and more efficient. However, controlling these qubits is extremely difficult. Small changes in the environment, like heat or electromagnetic signals, can easily disrupt them. That's why quantum computers need incredibly cold temperatures, close to absolute zero, to keep the qubits stable and functioning properly. So, the main question is, have we built quantum computers yet? The answer is yes, but they are still in their early stages. Companies like Google, IBM, and others have developed prototype quantum computers. However, they are far from perfect. One big challenge is that quantum computers only work efficiently at absolute zero, the coldest temperature possible, making them difficult to operate outside of highly controlled environments. Quantum computers hold the promise of revolutionizing various fields. For example, they could dramatically improve facial recognition systems, provide more accurate weather forecasts, and even crack complex codes, making them powerful tools for encryption and security. But with great power comes great risk. One of the biggest concerns is that once quantum computers become widely available, they could easily hack into personal and home computers, breaking through current security measures. So, what do you think about quantum computers? Are they the key to unlocking the future of technology, or are they too dangerous for our current security systems?